Okay, we're solving equations. Two-step equations means that you have to do two things in order to isolate x. So remember, to solve an equation, that means, here's an equation, it means you're trying to find the value of x that makes this equation true. Okay, so what value of x satisfies the equation? That's really what you're doing. Okay, and think about an equation like almost like a scale, like this is showing. So now there are more electronic scales that you might use in science, but this is a balanced scale where you put your object on one side and you have measured masses that you put on the other side to make it equal. Okay, so these we know are ones, so there's 1 plus 1 is 2. Here there's 4 plus 3 is 7 plus 3 is 10. So there are 10 here. So that's your 2, that's your 10. We don't know what this is. There's 4 x's. We have to figure out what it is so that this scale doesn't tip over, right? If the x aren't the correct value, then it wouldn't actually be balanced. All right, so how do we do that? You can think about taking off these two masses here. So that means if you take that off and you want it to be balanced, you've got to take 2 off the other side. So you can see these 2 are taken from here. Okay, so then that means that the 4 x's that you have, they can be shown anyway, there's 4 x's there, are equal to all of these masses. And so if we just group them into 4 groups, because there's 4 x's, you can see that each x has to be the same value, and each x is equal to 2. Okay, so that's kind of a pictorial representation of what you're doing when you're solving an equation. In terms of showing it mathematically, so what we're really doing here is subtracting 2 from both sides, and so then that goes to 0, so we get 4x equals 8. Then we're dividing that 8 into 4 groups, remember? So we're dividing by 4, so x equals 2, okay? Because those divide out, and 4 goes into 8 twice. All right, so that's what we're going to be doing for all of these. Sometimes the x is positive, sometimes it's negative, sometimes it's on both sides. So variety of types here. Okay, notice how it says express solutions in simplest form. So if it ends up being a fraction, reduce it if you can, but don't convert it to a decimal. Okay, so I'm going to go back to blue here. So 7x minus 3 equals 18. So think of it's basically the opposite of the order of operations. So that's another thing to think about. When you build an equation, first we start with x, in this case, then it was multiplied by 7, and then subtract 3 to get 18. So that was the order of operations. So the opposite of that is we've got to do the opposite order of operations. So subtracting 3 was the last thing that was done, so we add 3 to both sides, and so those go to 0, so we're left with 7x equals 21. Then the opposite of multiplying by 7 is dividing by 7, so when we do that, these 7's divide out and we get x equals 3. Okay, and you can always check your answer by putting it back into your equation. I do what I call a t-chart, kind of looks like a T, the left side of the equation and the right side. I keep them separate, but I put 7 times the x value that I think it is into the left, right side is 18, and I just check to make sure I get 18 for both sides. Okay, so that verifies it. That's called verifying, where you take the 3 and put it back in. That is not called solving it. So if you're asked to solve algebraically, that means you have to show your work. Okay, so I need to see at least this step and this one. Okay, you don't have to show the plus 3 or the divide by 7, but I need to see some work, not just x equals 3 and not putting it back in like. Okay, next one, we want to get the x term by itself. So that means we want to get rid of the 9 here so that it's over on the right with the other constant term. So in order to do that, sometimes you might want to circle the x term. If there's only one, you know you want to get that by itself. So that means I need to subtract 9, because that's positive 9 there, from both sides. And then that leaves me with negative 3x, and 21 minus 9 is 12. Then I need to get x by itself, so I've got to divide by the coefficient, divide by negative 3, and so x will equal negative 4. And again, you can verify by substituting back in. In C, kind of similar, except now we have 2 terms with x in it, so we need to get those together. So what I do is I always look for the smallest x term. Sometimes that might not be as helpful. You might want to look at, okay, if there is one x term by itself on one side, then maybe it's easier just to move the other one. In this case, it's the same term to move. So we want to get the x terms by itself. There's already 5x here. This is a positive 3x, so we're going to subtract 3x from both sides, so that goes to 0. And so that leaves us with, that leaves us with 5x minus 3x is 2x on the left. So my pen went a little wonky there. So that's 2x on the left equals 14. The opposite of multiplying by 2 is dividing by 2. So x equals 7. Okay, next one you'll notice, again, a term with x on both sides. This one is already by itself, so maybe it's easiest to leave that there. In any case, 5x is actually the smaller, so that's going to work. So I want to subtract 5x from both sides. So that goes away to 0, and I'm left with 27, because that's positive, equals 3x. Now I want to divide both sides by the coefficient of x, and I like to always show x equals. So the 3's divide out, and then I'm going to put x equals 9. I'm just basically reversing this equation. It's kind of like saying my name is Ms. McKay. So x is like my name is Ms. McKay, rather than saying Ms. McKay is my name. It's just not quite as descriptive. Okay. Next one, 2 x terms, one on each side. This one's by itself, so I want to add 6x to both sides to make that 0. And so 24 equals 8x. Whenever you're doing this, you always have to do the same thing to both sides. Whatever you do to one side, you have to do to the other. To make that balance, like we used back up here, we have to do the same thing. These two removing of 2 green circles, it's the same thing on both sides of the balance. It maintains the equation. Okay, if you don't do the same thing, then it's not a proper equation anymore. Divide by the coefficient of x, those divide out, and again, we get 3 equals x, but it's best to show it x equals 3. Next one, if you have brackets, I would rewrite this with just the single operation that's represented by subtracting a negative. That's two negatives basically, so it makes up an adding here, and then I solve the equation. So notice here, if I took the smallest x value or x term and subtracted it, in this case, that would be minus 4x minus 4x, and I get 0 on this side. So using that is not the best, or not the fastest anyway. Fastest is because we already have one x term on the right side, get rid of the x term on the other side. Now saying that, you're going to end up with a negative x term, and that's totally fine. It's just don't be careful. Don't forget to divide by -3. If you forget, then you're going to get the wrong answer. Okay, so those divide out. You get -7 equals x. So again, show it as x equals -7. All right. Okay, G, x is on both sides. Again, smallest term is 2x. If I subtract that, I'll have 0. So best in this case is to subtract 8x from both sides. Whatever you do to one side, you have to do to the other to maintain that equation being balanced. 2x minus 8x is -6x. So you can see the importance of knowing your integers. And then we're dividing by -6. Those divide out, and notice that -6 doesn't go into 4. But I'll use green here. 2 goes into 4 twice, into 6 3 times, and it leaves a negative. And we always like showing, so that's really 2 over -3, 1 negative, so keep it out front. Don't keep it in the denominator. Okay, that's not in simplest form. So the denominator always has to be positive. So you either show it up with the 2 or out front. And again, I like to show it x equals -2/3. Okay. Next one, again, you want to simplify the two operations there. So we've got 8. When you're adding a negative, it's like subtracting. And again, I've got an x term by itself, so I'm going to bring the other one over by adding 7x to both sides. Okay, so those go to 0, and then we get 8 equals -4x plus 7x is 3x. And then we divide by the coefficient of x, both sides, and you can see you get x equals 8/3. You can't reduce that. 3 doesn't go into 8, so you just leave it, 8/3. And we never show it as a mixed number. Next ones already have fractions in them. So think about what that means. That means x divided by 4 equals 20. So if you've got a denominator there, the opposite of dividing by 4 is multiplying by 4. So you're going to multiply, and usually I use brackets. You can use a multiplication symbol, but it might look like an x, so I use brackets. And then the 4's divide out, so I'm left with x equals 80. Really, it's important to check these. Do a quick check, left side and right side. So your left side is 80/4, which is 20, and your right side is 20. Okay, common mistake here. Students will say, oh, it's 20 divided by 4, which is 5. But if you put 5 back in here, 5/4 is definitely not 20. Okay, now we've got a couple of terms. Circle the term with x. So I need to get rid of the 5 first. So subtract 5 from both sides. Then I get, so those go to 0. So I get x/6 equals 12. Then I'm going to multiply both sides by 6. Those divide out, so I get x equals 72. Okay. Then again, circle with the sign in front your x term. So now I have to subtract 4 from both sides. Let's go to 0, so I get x/3 equals -15. Really important, again, common mistake, students will say, oh, that's -5, because they think of dividing -15 by 3. It's x divided by 3 equals -15. So now I'm going to multiply both sides by 3. Those divide out. I'm left with x equals -45. Next one, I have 2 terms with x in it, so I need to collect like terms. They're both fractions. Luckily, they have a common denominator. So really, I just add the numerators, keep the denominator the same. So that's 3x over 5 equals 12. Now I'm going to get rid of the 5 first. You can divide by 3 first, but I wouldn't. I'd get rid of the 5. Oops, there we go. And so I'm left with 3x equals 12 times 5 is 60. And then I divide by 3. And so those 3's divide out, and I'm left with x equals 20. Again, more than one term with x. This is x term. There's one by itself here, so I want to get the other x term over there by subtracting 4x over 6. Now you may reduce this, but I'm not going to because I know I have a denominator of 6. So might as well keep it. So I do it to both sides, so that goes to 0. Then I have 5x over 6 minus 4x over 6, which is 1x over 6, equals negative 9. And then I'm going to multiply through both sides by 6. And then I get x equals negative 54. And then same thing here. I have two x terms. I have one on the right, so I'm going to try to get the other term over. Luckily, they have a common denominator. If they didn't, you would have to get a common denominator. So that goes to 0. So I'm left with negative 8 equals 2x minus 4x is negative 2x over 9. So again, I'm going to do this in 2 steps. I'm going to multiply through by 9 to start, both sides. So that divides out. I'm left with negative 72 equals negative 2x. Then I'm going to divide both sides by negative 2. And then those negative 2's divide out, so I get x equals, a negative divided by negative is positive, 72 divided by 2 is 36. Oops, 36. Okay, then it says in question 2, solved algebraically, you can express solution as decimals rounded to the nearest hundredth where necessary. So you can use your calculator, but you still have to show work. Okay, so first thing is I've got just one x term here. So I want to get this by itself. So I'm going to add 9 to both sides. So that goes away. I get 4.2x equals, and then 9 plus 4.44. Well, 4 plus 9 is 13.44. There's no decimals here, so that it'll stay as 0.44. Then divide both sides by the coefficient of x. Okay, those divide out, and then get out your calculator, and you divide 13.44 divided by 4.2, and you get 3.2. Okay. Next one, you've got two terms with x. I'm going to, this already has an x on the right-hand side, so I'm going to subtract, get rid of the x term on the left by subtracting from both sides. Goes to 0, so I'm left with negative 4.5 equals, and 4 minus 6.5 is negative 2.5. You can do it on your calculator if you want, but that's what that's going to be. And then you want to divide by the coefficient of x. Those divide out, and then you'll get, if you're not sure what this ends up being, get out your calculator, negative 4.5 divided by negative 2.5. You should know, you don't even need to put the negatives in. A negative divided by negative is a positive. And then you get 1.8. So I'm going to do this in blue. So x equals 1.8. Okay. Next one, oops. So I've got x terms on both sides. The smallest term is this negative 4.8x. There's one x term on the right anyway, so I want to get rid of this term on the left. So I'm going to add 4.8x, always the opposite sign, so that goes to 0. And then I'm left with 7.3 equals. If you're not sure what 2.3 plus 4.8 is, do it on your calculator. You're still showing your work, so that's okay. So remember when we test you, some will be allowed a calculator, some questions, and some won't be. Kind of be split into two parts. So something like this might be with a calculator, but you still have to show your work. So that's a 1. Okay, so now when we now have to divide by the coefficient of x, and so those divide out, and then calculator 7.3 divided by 7.1, and this one we will have to round. It says nearest hundredth, so that's going to be 1.03. Okay, it says nearest hundredth where necessary, so these went to the nearest tenth. You don't put in zeros on those because it's not where necessary. You don't have to round. Those were terminating decimals. Okay, so this one we do have to round. Okay, and that's it.